JP currently is a robotics system engineer in the Maritime and Multi-Agent Autonomy group at JPL. After he got his PhD in electrical and computer engineering from Georgia Tech, he joined JPL. His research focused on new control techniques for multi-agent complex system and do it in a way so that the human can easily and effectively interact with them. And currently, he is the principal investigator of the NASA CADRE project, which is a lunar technology demonstration project for multi-agent rovers. And CADRE, C-A-D-R-E, it stands for Collaborative, Autonomous, Distributed, Robotic Exploration. And you know, for us, engineering geeks, we must have an acronym for our project. So with that, please welcome my colleague, Dr. JP Croix. So you see CADRE, one small drive for rovers and one giant lift for team autonomy. JP,
hello.
What is rover doing on the moon? Can you tell us more?
Well, I can do better than telling you. Well, maybe tell you and show you.
Okay.
So let's hit it.
All right, hit it, yeah.
So this is a video of our mission, the CADRE mission that you just introduced. It's all about multi-agent autonomy, so teams of robots working together. And here you're going to see them being visualized to go on a commercial lunar lander to the moon. They're going to get set down onto the surface of the moon. And I keep saying they because there's not just one robot, there's 3 rovers there. And they're going to work together as a team completely autonomously and cooperatively. So what does that mean? What are we doing with the robots from here on Earth? What are we telling them? Well, we're giving them really high-level instructions on what to do, like explore this area or work as a distributed instrument and gather this data in this area. And then they have to figure out everything else for themselves. So they go and figure out how to do that, how to collect the data, and they're going to aggregate that data and then send it back to us here on Earth.
Wow.
And that's happening, next year at the end of 2025.
Wow. And I thought it was so cool. When you said these rovers, they work in a democratic fashion. They actually elect their own leaders. So I was thinking, wow, are you guys starting a new democratic society, civilization on the moon? Is that it? Tell us more. That's crazy.
It's not quite that futuristic, but yeah, they do elect a leader amongst the team. So to be able to make a decision as a team, and they're a fairly small team of 3,
right,
or maybe 4 if you count the base station. They need somebody to make the decisions for the team and right, kind of keep the team together. So the way that they do the election is that first of all, they talk to each other. They figure out, well, who's online,
right,
what kind of resources do they have,
right,
how are they feeling, if you will, how much battery do they have left, and what's their thermal load. Also, who has all the information, because right, the one that has the most information is the one right, in a good position to make decisions right, for the team. So then they negotiate basically who's the best leader, and that robot gets elected as the leader and right, gets to plan for the team and take that position on. But if they need a new leader, they can go ahead and elect somebody new as well. So they can do all that.
Wow, that is just very intriguing.
Yeah.
So, JP, when I first met you, I was really impressed when you told me you wanted our student, the underserved, underrepresented student, to have access to NASA high-tech, right? And I was like, wow, that was one of the reasons that I found you just a magnet, right? We just have to work with you. Can you talk more about that, the idea of, making sure that our students have access to these really amazing technology from NASA?
Yeah, absolutely. So, we realize that robotics is a very multidisciplinary field. So you can't, do that on your own. It requires teams.
Right.
And these teams have to be, diverse, and not just in the expertise, but right, we also know that you want to have diversity in terms of, experiences, in terms of the backgrounds, in terms right, of perspectives, right, to build, successful teams that build these kinds of right, amazing systems. So I think it's just natural to kind of see that being as inclusive as possible builds the best possible team to solve these problems in the best possible way.
Right.
And I think you and I have been kind of working together, you know, specifically on making this more inclusive by you know, basically working on accessibility. Accessibility is, you know, is something that you need to have. So I think I'm really excited about the work that we're doing together, both in terms of, you know, having your students, you know, build some of the technologies that we've built, both in terms of the hardware, in terms of also the software, but, you know, also the discussions that we've been having about test beds, because, you know, having a place to do robotics is also important, right? Because these things are embedded into the real world.
Yeah, thank you so much. I think, you know, that idea, the inclusive principle, the principle of accessibility, I think that's, you know, 100% aligned with our institution, what we're trying to do here. And oftentimes it's all about creating opportunity for our students. And yeah, so JB, as was alluding to, we are collaborating and create a sibling of CADRE, right?
Yeah.
And we, again, engineering geek, we must have an acronym.
Absolutely.
And the name is CoHORT. What is CoHORT for JP?
I think that's your brainchild, so you should present it.
Okay, yeah, we was talking about that, and CoHORT is cooperative human operation with robotics teams, right? Yeah. So, did I get that right?
Absolutely, yeah.
I believe that term was coined by JP, so full credit to him. Yeah, so CoHORT is one of these, again, you know, rover, multi-agent rover platform that we are developing to support a lot of really amazing research in autonomy. For example, in resiliency, if something to go wrong with them, oh my God, it's coming out.
I'm hearing something sneak up on me.
Wow.
Whoa.
Wow. Oh. This is CoHORT, everybody. Yeah, so JB, this is the test version, right, that you used for testing CADRE, is that correct?
Yeah, correct. This was based on this is based on the design of one of the very first versions of the robots that we built for CADRE, specifically to test autonomy, to be able to produce many of them. Yeah. So because, you know, the more the merrier in terms of multi-agent systems, right? So yeah, and we know that you know, we're stronger together, so. Yeah,
this is so amazing, everybody. Next year, when you come back here, you're going to see many, many more of these CADRE sibling cohorts. So JB, what's in the future for CADRE? Where are we going?
Yeah, that's a fantastic question. I mean, I think really the primary objective for us with the CADRE project is to really be an inspiration in terms of convincing people that, you know, multi-agent systems and multi-agent autonomy is a technology that we can use in the future that also enables completely new capabilities in terms of the way that we explore the solar system and that we can do science. And I'm really hoping that folks feel inspired to now start thinking about, you know, what kind of, you know, team of robots can I build? You know, certainly even beyond what we've done with CADRE, we've got, you know, 3 of the same robots, but what can you do with a heterogeneous team of robots that, you know, dissimilar robots that come together to solve completely new problems? So, and that's really what I'm looking forward to in the future.
That's such an awesome, exciting future and vision, and we can't wait to, you know, do that with you. Last question I must ask you, because we talk about Da Vinci, right? So if Leonardo da Vinci was to wander about JPL, right, and have a conversation with the team, what do you think his reaction is going to be?
I think you'd be really ecstatic and really excited to talk to everybody and kind of have an opportunity to learn from him, right? I mean, he's you know, well known for being an expert in many different areas and having interest in many different areas, so that I can understand more and more about the world that he was in. And I think it's kind of the same spirit that we have also at JPL. Like, we're all certainly experts in our different areas, but then because we work with, you know, so many different people, we kind of start learning things from other people and expand our knowledge. And I think he would really. You know, kind of, that would really resonate with him. That's still happening in the future, and that's how people are successful. And in creating these technologies.
Yeah, that's certainly quite an exciting future. And I guess in part way, let's just do a high five, right?
Yeah.
But I guess we don't do high five. We have 4 wheels, so we're going to do 4, 5.
Okay.
Touching
1,
the
2,
wheel,
3.
right? Yeah, there you go.
There you go.
Everyone, please give it up to Dr. JPL Croix and the whole JPL organization for supporting our program. Yeah. Thank you, JP.